The erosional coastal landforms offer some of the most spectacular landscapes due to waves breaking against irregular shorelines. Along many active continental margins, rocky shorelines are fringed by mountain ranges. A very good example is the coast of Chile, where the Andes Mountains result of a collision of oceanic crust and the continental mass. Even when most of the people are not familiar with rocky coastlines because many coastal cities and even vacation sites are located mostly on coastal plains, at the mouths of estuaries, and in other lowland areas, for example touristic cities on east coast of United States, the pounding surf and breaking waves on rocky coasts have long been a source of inspiration for ocean lovers. In Mexico, the states of Baja California, Oaxaca, and Guerrero offer a plethora of tourism destinations that showcase the rugged beauty of these coastal landscapes. It is estimated that 75% of the world's coasts are rocky, where their hard and resistant composition exceeds the erosive capacity of the waves and therefore erosion occurs very slowly. This is, from a few millimeters to centimeters in a century. In this lesson you will discover the extensive variety of coastal landforms generated by the force of waves. We will start with some of the bigger erosional coastal landforms. Headlands and bays. Alternating layers of hard and soft rock allow the sea through the wave attack erode the soft rock faster, forming a bay but leaving hard rock sticking out, forming a headland. The altering rate of erosion of hard and soft rock is known as differential erosion. As the bay develops, a process named wave refraction will occur around the headlands, changing the way that waves attack and increasing erosion. However, away from headlands, the energy of waves will be lost, leading to the development of a bay. In further sessions you will learn more about wave processes such as refraction. For now, just look at the diagram and a real picture of a headland. Red arrows show the wave energy converge at the headland. Yellow arrows show the loss of energy by the divergence of waves forming a bay and promoting beach existence. This image shows a discordant coast with a sequence of bays and headlands. These lovely sandy bays are formed as the weaker section of coastline here have been eroded. The headlands stick out as they are harder, more resistant rock which are not as easily eroded.
The next coastal landforms are usually developed in a sequence: sea cliffs, wave-cut notch, and wave-cut platforms. Let's begin with the cliffs. Cliffs are steep, usually more than 40 degrees, but often very vertical formations created by the coastal erosion processes explained before. They are generally formed as the result of marine erosion at their base, accompanied by subaerial erosion at the top. Steep cliffs are formed where the land consists of hard, more resistant rocks and where their height obviously is being determined by the difference between the sea level and the level of the land. Hard rocks erode, and the less fractured the rock is, the better will resist breaking down. Igneous rocks such as granite and basalt form vertical cliffs. Such cliffs can withstand constant pounding by more energetic waves. Cliffs are more affected during storms. This happens when the cliff base is undercut by the hydraulic pressure of wave impact, and the abrasive action of water and rock fragments during storms repeatedly hit the cliff base. On the other hand, softer rocks such as clay and some sandstones erode more easily and can create more gently sloping cliffs, although this is not always the case. Image below shows the cliffs on the California coast. Here, cliffs are formed by alluvium, a type of sedimentary rock more prone to erosion. The retreat of cliffs, particularly those of softer rock, can supply a wide size range of sediments to the beaches. The next erosional landform is the wave-cut notch. A wave-cut notch is simply a groove, notch or indentation formed along the base of a cliff when are undercut by the sea. Wave-cut notch occurs where the waves break against the cliff and where erosion is most powerful. The photograph shows a wave-cut notch being formed at the base of a cliff. The waves can erode only the parts of the cliff that they can reach, so the base is eroded faster than the rock above it. Eventually, the notch affects the cliff stability, leaving the rock above it unsupported and liable to collapse. When the unsupported rock collapses, the process is then repeated on the newly exposed cliff face and a new wave-cut notch is formed. This will cause a cliff retreat. Next video shows the hydraulic action of waves. Find the wave-cut notch.